Hi, today we're going to be doing lesson 2.3, which is a three-step process to solving, and we're going to focus on step 1, which is simplifying the equation through the parentheses and like terms. The objectives of this lesson are to simplify an equation with like terms and solve, simplify an equation with parentheses and solve, and learn to recognize equations with infinitely many versus no solutions and use the entire three-step process to solving in mixed practices. The goal of the three-step process is to get x alone where x equals any variable. So first you simplify it, which includes distributing across parentheses, getting rid of fractions, where you could even multiply all by the LCD if necessary, and combine like terms and get all x's on the same side. In addition, you can also use the addition principle and the multiplication principle. Follow these guidelines to combine like terms and to simplify x. First, you combine like terms on the left side of the equal sign, then you combine like terms on the right side of the equal sign, and then you get all your x's, which are your variables, to one side. So first, let's solve this problem. So the first step is, we see these parentheses, so we're going to distribute 9. So we're going to solve the parentheses like we already learned how to do. So we're going to get 9x plus 18 minus 4x, and we're going to carry the rest of the equation down. Next, we're going to combine all of the numbers with x inside of it. So 9x and negative 4x, and 28 and 2, because they are like terms. So upon doing that, we're going to get 5x plus 18 equals 30 plus x. Now, we're going to subtract 18 from both sides and subtract x from both sides. So now we're done with that, and we're out with that, which is going to be 4x equals 12. And we're going to divide both sides by 4, which we're going to get x equals 3. Let's do another one. So the first step in this problem would be to first distribute into the parentheses. So we're going to distribute our 2 because that is the coefficient outside of the parentheses. So then we're going to get 24 minus 6x plus 8 equals negative 4. Then we are going to combine all the like terms on each side of the equation. So 24 and 8 would make 32. And we're going to carry down the rest. Then we're going to subtract both sides by negative 32, which is going to result in negative 6x equals negative 36. And then we divide both sides by negative 6, and we're going to get x equals 6. So when you distribute across parentheses, you use the order of operations to simplify equations by working across the parentheses first, not just inside them, but distributing into them. So would you agree that 3 times 4 plus 3 times 7 equals 3 times 4 plus 7? So you get 3 times 4, which is 12. Oops. 3 times 4, which is 12, and 3 times 7, which is 21. And when you add them, you get 33. With this one, you distribute the 3 to both the 4 and the 7, and you're going to get 11. Or you could also just add on the inside and then multiply. You could do it both ways. What about this? 4x plus 4 times 6 equals 4 times x plus 6. So you're going to distribute on this side, and you're going to get 4x plus 24. And on this side, together, 4x plus 24, it equals. It's easier to do these problems once you understand how the principle works. Now we're going to simplify this new problem. So the first step is to distribute this 4 and this 2. So when we do that, we're going to get 4 bracket 6 plus 6x minus 3x equals 6 minus 10 plus 2x. Now we're going to distribute into the brackets. So we're going to distribute this 4 to all 3 numbers in the brackets. When we do that, we get 24 plus 24x minus 12x equals 6 minus 10 plus 2x. Now we're going to combine like terms using both x and just regular like terms. So we're going to get 24 plus 12x equals negative 4 plus 2x. Now that we've simplified all that we can, we're going to get all of x's on one side. So I'm going to subtract 24 from this side, and I'm also going to subtract 2x from this side. So now we're going to get 10x equals negative 28. Once we divide both sides by 10, we'll eventually get that x equals negative 2.8, which is correct. So there are some special cases in which the answer you get is not actually a number, it's a different kind of solution. So if we try to solve this problem right here, 2x plus 1 equals 2x plus 1. We subtract 2x from both sides, but when we do that, we're gonna get rid of 2x altogether. So 2x won't be there on either side. So we're gonna have 1 equals 1. When we get answers like that, the solution is actually all real numbers. So if the two answers that you get are the exact same number, the solution is all real numbers. Let's look at this case. If we get 2x plus 1 equals 2x minus 5, we subtract both sides by negative 2x, we're going to get some crazy response once x is vanished that 1 is equal to negative 5, which is definitely not true. When we get responses like this, it means this is wrong. And these examples, I accidentally copied them over. These examples don't apply. But the x is vanished, and when you get responses when the two numbers aren't equivalent to each other, then the answer is no solution. Thank you.